the presentation. So they put the presentation under the business track. How many people are hoping for a business side of should our organization use Hadoop? And then how many people are looking for more of the technical side? So business side, okay, and technical side? Okay, okay, we can do little bits of it. Okay, and who's using Hadoop currently? Who's piloting Hadoop? Okay, and some familiarity with some of the basics. The 3 V's of big data. Who's familiar with the 3 V's? Could name one of them. Okay. Okay, so that gives me a good idea. Who knows what pig or hive is? Okay? Okay.
Is that a trick question?
Yes, yes. It's Utah. Hadoop, hive, pig. Okay. So we'll wait a minute for people to come in and then we'll start things up. I've got a lot of information to go over so while we're waiting, Pat Wright is doing, we've got the Hadoop cluster right now. So Pat Wright is doing a presentation on integrating, they had a relational database management system at their organization and they went over to Hadoop infrastructure. If you want to go over to that presentation, I told Pat that we may have people that will head over there 5 minutes, so he's expecting that you may be jumping in. He's given the presentation, it's gotten very high marks. Several of our students, I teach up at Utah State University, several students really enjoyed his presentation, and he allowed for a lot of Q&A within his presentation on different strategies for presenting Hadoop to an organization. The presentation that I'm doing is, there's a lot of slides in this slide deck, so I'm going to pick and choose which slides I'll talk about. Get back to, if you want to watch Pat's presentation, there is a recording of a presentation he did at U of U on YouTube that's recorded fairly well. What I'm doing is kind of giving people cliff notes of Hadoop so that you have enough information to be able to select what are the areas of Hadoop that are important to me that I want to learn more about from a personal point of view as well as an organizational point of view. So definitely go to the joined in and download the slide deck. The goal is, if you want to learn more about Hadoop, to take the slide deck and go through and find out, okay, I want to learn a little bit more about Hive, I want to know a little bit more about Pig, I need to know how to integrate Hadoop in with our relational databases. I know SQL already, so these are the tools that are easier for me to use.
Welcome to Openwest. We're glad that you could all make it. This is John Weeks, and he will be presenting what's the hype about.
Thank you. So we're going to have people coming in and heading out from time to time. So I got a chance to talk with some of the people beforehand. We're going to do a presentation on focusing on, is your organization interested in doing Hadoop within the organization? Is Hadoop the right type of tool for the organization? As well as a heavy emphasis on the technical aspect of it. We'll be reviewing some of the terminology that is common within Hadoop. The Pat Wright is presenting another presentation at the same time in LA 101. There's a recording of a previous presentation he did at Review. He has a session that involves a lot more Q&A and talks about their organization and how they took relational databases and moved over to a Hadoop type of environment. So Hadoop has gotten a lot of press because big data has gotten a lot of press. Big data is very powerful for a lot of organizations. It is enabling a lot of organizations to beat out their competitors, to improve their revenue significantly, and to interact with their customers much better. Hadoop has gotten tied in with big data because the first organizations that had problems with big data were Google, Yahoo, Facebook, these really big giant companies with hundreds of millions of subscribers that are starting to take over the planet. That Facebook, there are more people that are subscribed to Facebook on the planet than are not subscribed to Facebook. So being able to manage all of those people and to be able to understand what are the customers doing on the site, how can they change the product to better serve the customers. They had to use Hadoop within their organizations, and other organizations are saying, look, we need to improve our revenue by 10%. We can do that through data analytics. Everyone else is using Hadoop. We should do Hadoop. Let's buy a $2 million cluster for Hadoop and solve the world's problems. When we install a Hadoop cluster, that will increase our revenue by 10%. That's not always the case, and we'll take a look at some of the cases for that. From a personal perspective, learning Hadoop, why would you personally want to, there's the question of why would your organization want to use Hadoop, and why would you personally want to use Hadoop? This is a Dice.com salary survey from 2015 here, and then some highlights from 2014 and 2013. And the topics highlighted in green are all Hadoop-related topics. Hadoop is made up of a number of different tools. It's not just one single tool. It's a lot of tools that you have to integrate together, and you may not be implementing all of the tools. But typically what's happened here is you're looking at things like R. The salary differentiator, the average salary for someone with R skills is $115,000 back in 2014. That's still pretty close to the case, that R is just a couple slots down, but Hadoop skills have leapfrogged over that, and there's such a demand for Hadoop-related skills that the salaries for IT folk have typically been 20 to 30% above their peers. So it is a valuable skill to add to your resume because it is in demand. So why is your organization interested in data analytics? You could start out and you could say, hey, we want to implement Hadoop, and the first year, you're typically not going to be pulling in profits right away if you're trying to put a Hadoop cluster in as your first goal. You're likely going to have a burn rate of $2 million for a larger organization to pilot a Hadoop project. You can do it at smaller scales. We'll talk about Amazon Web Services as a good solution for trying it out at a smaller scale. If you launch the project and it's the wrong match for your organization, you've wasted $2 million. You've put the wrong solution in, and you're not going to see significant gains. If it is the right solution, it can end up being a year-over-year gain, that you're going to improve sales by $12 million. You're not buying a product for ultra cheap. You're not getting a bargain rate on some hard disk that you're never going to get that bargain rate again the next year. You're installing a solution that is going to improve the company year after year. So you improve the profits by $12 million the first year. That's in $12 million of additional revenue you're going to get for a couple of more years, and you're going to continue to improve on the solution. So the company's revenue may be, it's sometimes difficult to directly link this $16 million came from this data analysis. You've got to take a look at where you are today, clearly measure, this is where we are today, these are the improvements we made, this is how we saw customers went from buying $100 worth of product on a purchase to $200 on a particular purchase. And typically, the companies that have seen success have seen year-over-year gains. That's not $12 million you're going to have added to your bottom line. the first year and the second year. It's going to be a little bit more the second year, a little bit more the third year. I asked some of the people some of these questions before to get a sense of the audience. A couple other questions. OLAP and OLTP, who's familiar with those terms? Okay, a couple of people. Okay, this is just so I know which slides I should flip through quickly and which slides I should spend a little bit more time about. So some of the other fun things related to it, we'll be talking about like where these crazy names came from, Hadoop, Mahout, Uzi. The 5 V's of big data is an important area to go into. That started out with the 3 V's of big data, what really defines big data. And it was volume, obviously, terabytes and terabytes of data. The variety of data, you don't have just SQL data coming in, you've got information about your customers coming in from Facebook, from your customer service centers are recording the conversations, converting that over from text from voice into text, being able to analyze that information. You have vendors that you're interacting with that you're able to pull in their information. And it typically all comes in. Not everyone is using MySQL for their organization. Many of the organizations are using different tools. And then the velocity of the data that's coming in. When something happens, Thrive was presenting in here right before this, and they were noticing that Thrive does canned foods for emergency supplies. If the power goes out and everything, you open up your emergency rations. They do a great job. We use their product. And they've noticed right after any type of natural disaster, they get a lot of people ordering their product. They become emergency prepared. So you want to be able to identify what are the trends that are happening, what are the product reviews that are happening, and correct those very quickly. Sometimes it's changing things on a daily basis to say, hey, we suddenly got a lot of complaints about our batteries and our laptops. We need to fix that right away rather than waiting for a 3-month recall on the solution. Other times it's things like the presidential campaigns and the political races. They do a town hall meeting and people are tweeting real time to be able to go in and take a look at thousands of tweet messages saying, is this something positive or is this something negative? And in the course of a 1-hour meeting to be able to go in and say, let me talk a little bit more about this particular campaign we're talking about. The other views that have been added on, first there were 3 views, then there were 4, then there were 5. Veracity was added in veracity is, do we believe the data? Do we believe the analytics related to that? I'll talk about that on a slide in the future. And then my favorite is value. The analytics that you're doing, are you having bottom line value? If you can list the top 10 French pop singers instantly, that just doesn't give you a lot of value. If you can say, a customer who buys this HP inkjet printer is also going to buy this toner 3 months from now, let's send them an email letting them know their toner is about to run out. Do you want to buy it at a 40% discount and start getting return on revenue rather than losing that revenue to a customer because they went down to Staples to get the toner? I'll flip through these quick. Volume. Data is growing huge. The estimates, in 2009, some people thought we were at 500 million terabytes, 500 billion terabytes of data. Some people say it's 800. They don't really know. It's hard to get a good solid figure on that. Some of that they do know is how many hard drives Seagate and Western Digital sold. We know that disks have gotten really cheap and they're continuing to get cheaper, and people are able to collect a lot more data through the web and through sensors and interacting with each other. The data is coming in through structured formats. but 80 to 90% of the data that's out there is in unstructured formats related to typically text documents, but you also have images that are being identified so that you can identify, there's facial recognition, that stuff gets a little scary in my book, but also being able to look at photos and say, hey, I want to look at all of my photos that have my cousin Jim in it because it's his birthday. I want to collect those photos. Things like that can be handy, and companies are coming up with more and more creative ways to get value out of that information. The text sentiment analysis is a big one for being able to look at Facebook and Twitter comments of what do people think about our products, what are the good parts and the bad parts of the product. When Apple Watch came out, what are the good things about Apple Watches? What are the bad things like the battery life dying? These are the things we need to correct in our next release. The velocity of the data, some groups need real-time data analytics that when you swipe your credit card, the credit card companies want to know within 3 seconds, should we approve this credit card transaction or is this fraudulent? I get a call about once every 3 years saying someone in Korea or someone in Ireland tried to use your credit card. This was an obvious flag that I wasn't in Ireland at the time, especially when they called me to say, did you order this product? A little slower velocity, Google Flu Map, the Center for Disease Control would put out their studies on when was the flu peaking and how rapidly was it accelerating, sometimes months after it had peaked. Google identified that people tend to search for runny nose, cough, medicine, should I take this medicine with this? And based upon those patterns, they were able to predict when the flu is peaking, when should the vaccines be put out, where is it peaking in different areas. And they've been really accurate at being able to take a look back and take a look at the CDC information and see this is accurate. Obama used sentiment analysis in his last campaign. Lots of stats on what people are doing every minute. Lots of people are doing lots of things every minute. In particular, my key thing with all of these reports is taking a look at the value of the report. When the report is generated within the IT department and it never leaves the IT department, the value becomes typically 0. If no one's going to see your report, the report is a value of 0. What are they going to do with the knowledge? If no one's planning to make any changes related to the reports that they're receiving, your report has 0 value. You're not changing anything in the corporation. That the effect that you had within your organization amounted to nothing, and you're not adding that value. You're not going to see those millions of dollars returned. One of the ways to think about what should we be doing is what's the competition doing? It's hard to have a discussion and say, if we knew our customers better, we could sell this product better. It's easier to go to the board and say, if our competition knows their customers better, their sales are going to increase by 20%. Where's that sales increase of 20% going to come from? Is it going to come from us? Is our revenue going to go down 20%? And then we're going to try and play catch up with the other competition. So responding to the competition before it becomes a case of too late and you just don't have the revenue to invest in data analytics projects. So veracity, 18% of statistics, no, 23%, 59% of statistics are made up on the spot. Values like that, the board just doesn't like. That you can come up with numbers lie, we've all heard that type of thing before. If you present your reports, the board may simply say, we don't believe your analysis. We want to rely upon our intuition, and it can become very difficult to go in and prove. Typically, you have to do kind of an A/B test of if you're a retail store, let's do data analytics at this store, see if we can increase sales. then let's compare that to the stores where people have used traditional intuition to make their case. The other problem that people run into is the data accurate? Were the methods used to collect the data accurate? Did the information come from an internal source? Did it come from your department? Did it come from another department? Was the data fudged in order to make someone's numbers look good? Many times you will see things like 3 out of 4 departments at an organization had revenue increases of 50%, but the company overall's revenue increased by 5%. The numbers just don't add up. When you look at the bottom line figures, did it really make sense? And a lot of organizations have had that false information over time. The problem people are trying to solve with big data, and particularly looking at Hadoop solutions, is when your big data becomes so much that you can no longer do the analysis on a single computer, or in particular within the amount of time that you have available. If you need to get results out within 5 seconds, your laptop may not be able to provide those solutions quick enough. Google wants to get their search results to people in 0.2 or 0.4 seconds. So very rapid turnaround of the information. They don't want to wait, say, let's wait 2 hours to see what your search results are. So depending on your particular needs, you may need to do the analysis very quickly, is why you need to scale beyond a single laptop. Many times if you have data between 2 and, I'm going to change this 32 gigabytes to 20 gigabytes. So if all of your data is between 2 and 20 gigabytes, and you're generating quarterly reports for your organization, a laptop is sufficient for doing your analysis. Don't go out and buy a Hadoop cluster if you only have 8 gigabytes of data to analyze. Go out and start collecting all of the data you might need first using cloud solutions. If you've got 20 terabytes of data, like an insurance company, that you want to analyze the data, you might know, okay, we need to go in for a Hadoop cluster right away. So looking at where the data is stored within the various organizations. I apologize that this one is hard to read. The analysis here is by industry, how much data is available within the industry, how many organizations are there in that industry, and then what's the average size of data within each of those organizations. So what that's saying is, discrete manufacturing, there's a lot of data, there's a lot of organizations, so the average amount of data, 967 terabytes per organization, is fairly small. In contrast, securities and investment, they've got a little amount of data, but a much smaller number of organizations, and the amount of data each organization has is on the order of 4,000 terabytes. So looking at the different industries, it can definitely vary how much data you have. And this doesn't say, is this individual elements, or are people storing 15 gigabyte images where they just don't have, they might have millions of pictures, but other people have trillions of data elements. Looking at a one system solution versus a multiple system solution, this is taking a look at a beefy Dell server that the top end that you can order online from their system versus ordering a whole bunch of their desktops. There's lots of different configurations that you can order, but basically for $66,000, you can get 2 terabytes of memory. So if you have 1.5 terabytes of memory, you can order one box that you can put that entire database in memory for very rapid analysis. Similarly, you could buy 50 different Optiplex desktops at $63,000, and you would have a very similar system. You would have 50 independent cores versus 40 cores that are all in one box. The big difference is the amount of data that you can store in the units. Within the server, you end up getting about 5 terabytes of disk storage directly on the unit. You can order other external data units that tend to be pretty expensive if you optimize them for performance. But you're getting 16 hard drives there. With the desktops, you can put in 2 really big, inexpensive hard disks that are pretty cheap, and you can end up with 15 terabytes of usable space. And instead of 16 spindles that you have spinning here, you have 100 spindles. You have 100 disks that are pulling the information out. So your disk access can be about the same price with a notable performance increase related to that. Also, with this commodity solution, I may have this on a future slide. With this commodity solution, if you lose one of these individual desktops, you go out and you buy the newest, latest, and greatest desktop to plug it in. Hadoop helps you manage when you've got 50 systems and 3 of them went out. Hadoop is helping you manage those down systems so that becomes transparent. When an individual system goes down, you don't have to restart your analytics. Yes?
Do you know the difference in power consumption between those 2 options?
Oh, a lot.
I mean, obviously, like one server, it's 10 cores, so I mean, I've dealt with servers that have blades in them and stuff, and
yeah.
you can definitely tell, like when you pull one of the blades out, it's like unplugging a whole computer. But you know, I'm just wondering, you know, like dollars to cents. Yeah, maybe you get like they're similar, or you save some, or but I mean, are you going to pay up the wazoo?
So I'm going to summarize that quick. Power consumption, win, lose. Okay. If you're putting this cluster in, find a place that has cheap power, and you don't buy 50 desktops, you buy 50 blades, which they're cheaper than this, but then you have to manage custom solutions. So your power consumption, you will consume a lot of money here, but your total power cost, it's bad for the planet, but the data analytics solution should pay for the power without any problems.
Okay.
But don't pick San Diego, California for high expensive power use like hydropower someplace else.
You can also make that geographically diverse, right? So you can have some in San Diego and some in Utah.
No.
The 50, I'm saying.
No, you would typically...
Oh, you're saying within one Hadoop cluster?
Yeah.
Without mirroring them.
Yeah, so if you have 12 different Hadoop clusters, definitely they would be all over the place. But you definitely don't want to be pulling Hadoop into different geographic ranges. You want to have them in the rack next to each other. There's always exceptions, but generally next to each
Kind of like Cassandra, you'd have like one, the ring would be in the same, within the same data set.
Yeah.
Got it.
So one of the other things to take a look at is, were you having disk performance or were you having GPU performance related issues or CPU related issues? So back here, we're looking at 50 cores. If you put in a $5,000 GPU unit, you're getting 5,000 cores. So there's a lot of activities. So particularly machine learning over here, it tends to be very CPU intensive. You can put a GPU in a single $2,000 system. You can put 8 GPUs into a system to get a heck of a lot of cores. And you can really pound through CPU intensive activities without having to go into the server market. So CPU oriented activities, you can take a look at some of these and decide, is this something that's so CPU intensive, we should just go with the GPU solution for a lot cheaper and much faster results. So your traditional cluster environment tended to be, you buy one of those $60,000 machines, you need to scale it out, you buy another $60,000 machine, you keep buying more of those, you try and integrate them together and you attach them to a central storage unit. And that model works pretty well except for the price, the complexity of managing the systems, and the scalability of the solution just doesn't end up working out, that there are some maxes that Google would not be able to operate at that large scale. They can have some of those, but for the really large scale solutions. And the pricing model for the commodity hardware is changing. The commodity hardware and the servers are both getting cheaper and faster. One of them goes, you simply replace it. With these, you buy one of these, you've got to buy a 10-year warranty to keep managing that particular system. If one part fails in that unit, do you have to throw out that whole unit or try and buy a replacement for that unit on eBay? The replacement cost and warranty and service for these solutions can add up very significantly, whereas these systems, you don't buy warranty, you don't buy service contracts, you just buy the replacement unit. If that system's a year old, I don't want a year-old system, I want the latest and greatest system when I plug that in. And Hadoop helps you manage that, having a system with a faster CPU, a bigger disk, faster overall systems.
Just super quick comment.
Yeah.
It's funny because when you say bad for the planet on using too much energy, you have to balance it out, right? Like, you just had to manufacture, 3 new computers, versus, so if you're using more power, but you're actually, like when you look at all the variables, it's probably better to use a cluster. Instead of building a whole new, system, you're just replacing a little piece of it.
Right.
So it's kind of like, do you buy a Prius or just drive a Hunter Suburban?
Yeah, the Prius is better for the planet, but
in terms of manufacturing of the batteries, it's not, right? So
Right, yeah. And in terms of your wallet, you're probably paying a lot more for your repair costs. So, yes, so everything you definitely have to balance out the whole picture. So the cluster solution tends to be an all the eggs in one basket solution. You've got to invest heavily in your warranties. The multiple independent systems, that warranty cost is a substantial part of IT. The power can be paid for in terms of the warranty savings alone many times. And your ability to scale, typically Hadoop is more of an 8 to 400 node solution. Yahoo has a cluster running 4,500 nodes, but that tends to be more of an exception, that you're not going to be able to manage it with a small team of 1 or 2 people managing those nodes. You also have a significant advantage here of if you've got 50 or 100 systems and you want to take 20 of those systems and repurpose them to another job, you can do that fairly seamlessly, whereas if you only have 3 large clusters, it becomes much more difficult to say, give me half of this individual machine. And as things tend to go along, when you free up systems, you decommission some of the nodes, you can oftentimes find another purpose for those pretty easily. In terms of trying to find a size for the clusters, Hortonworks has a solution that you can go to the guide and plug in a number of numbers and they can estimate how big a cluster you might need. Many organizations don't find that they have that large a need, that they don't have 20 terabytes that they need to have processed within 3 hours. So a lot of organizations that are out there just need data analytics. They don't need the cluster. A lot of organizations start out and Excel pivot tables are enough for them. Excel's Power BI suite, if you're a Microsoft shop, that works particularly well. They seem to be trying to catch up with the Tableau solutions that have been out for about 4 years. I really like Tableau. It's $1,000. They've got some open source products. They have a public Tableau solution. If you have open public data, you can view your information along with the rest of the world on their public sites. It's a great visualization tool for being able to understand your data very quickly, that you can take lots of columns of data, move them together, compare customers over a year with interest in different products, which products have higher defects. If you have the data, it can analyze it. It tends to be memory dependent on your system. So if you've got 64 gig of memory, usually you can process 48 gig of data within Tableau. You can't process 20 terabytes in Tableau that I've seen solutions for. And going a little bit larger, many organizations find that putting the data out there where the whole organization can look at the information, particularly looking at setting up key performance indicators, metrics that say these are the numbers that are driving our organization. Qualtrics has been doing a fantastic job of raising revenue and doing surveys with college campuses. Their KPI was how many college campuses do we have a contract with? And they were just trying to drive up that number. And every employee knew how many colleges they knew that Qualtrics was out at, that they were very transparent about a lot of their data. And when people see the individual goals that they're being measured on, they tend to try and deliver on those. To be able to look beyond just that single number, to be able to analyze the company's data, doing an OLAP cube. I'll talk about OLAP in just a little bit, but it's basically a self-service tool where people can go in and they can analyze the company's data, they can look at it, they don't have to have technical skills, they can say, show me the sales for the Western United States over the past couple of months for this particular product range, and they just get the results nearly instantly. The challenges with data analytics, I alluded to value before. Do you have a data-driven culture? If your organization is not driving around the KPIs, if the KPIs are not front and center in front of every employee, you're not a data-driven culture. That when you put out a report once a quarter and it gets ignored, you're not a data-driven culture. You're not going to make change. So you do have to change the organization, put the data and the reports out there, let people know how they're going to be measured, and try and drive the results around that. You've got to get executive support. If the executives don't buy into the veracity of the data, you're going to lose. And then when you start sharing the data between different departments, a lot of people find they really want to own their data within their organization. They don't want to share it with other people. They don't want other people running numbers to see how they're actually doing. So that can be challenging. I'm going to quickly go over conformed dimensions. Data is set up in many different departments, and many times the data doesn't, when you try and pull it together in one location, it just doesn't mesh. So conformed dimensions and definitions are things like, at Utah State University, I go and I ask, how many students do we have at the university? I get answers of 12,000, I get answers of 25,000, I get answers of 18,000. One question should not have multiple answers. The problem is people have different definitions of the number of students. Did you mean the number of students on the Logan campus, the number of full-time students, the number of total students, the number of credit hours? So it's an example of that. So a quantity of one, when you're talking soda, if you buy a single can, you go up to the cashier, you want to be able to buy 1 can of soda for a drink of Sprite. The cashier can ring you up as a quantity of 1. The person stocking the shelves, they stock it by 6 packs and 12 packs. The delivery person, you call up and you say, I need 20. They're going to send you 20 pallets. They're not going to send you 20 cans. You call the factory, I want 20. They're going to send you 20 trucks. So when you get numbers of, did we ship out 10,000 trucks of Sprite? Well, 10,000 trucks of Sprite is a lot different than 10,000 cans of Sprite. So getting onto OLAP and OLTP, this gets into one of the top job interview questions. You go into data analytics, what's the difference between OLTP and OLAP? OLTP is transactional databases, OLAP is analytical databases. Transactional databases are the databases we work with all of the time. That someone wants to purchase something, if they go into a transactional database, they make the purchase, quantity goes down by 1. If we try and run reports on this, our service time goes down. That the ability to check out from Amazon.com when you're running a report on all of their data for the past 10 years, you can't have that slow down to 1 minute to do a checkout. You want that instant. So people copy the information over to a secondary source called an OLAP, or an analytical database, where you tend to go in and you analyze all of the rows or a large portion of the rows in your data, whereas transactional data tends to be pulled in one row at a time. I'm going to flip through a large set of the next slides to get to toward the end of what you should be doing next. If you're interested in learning more about Hadoop, some suggestions for how to become more familiar with Hadoop. My biggest suggestion would be download the Hortonworks Sandbox, play with that. Particularly their tutorials are very helpful for an organization or for an individual to be able to understand Hadoop quickly. You can walk through a lot of the tutorials in 20 minutes. Cloudera is the leading Hadoop distribution. They have a dominant market share, but their tutorials have been very problematic. That they tend to, not all of Hortonworks tutorials work completely out of the box. They do run into bugs, but the Cloudera tutorials tend to be much more buggy. So I would say learn Hadoop using the Hortonworks tutorials, and then you can choose to migrate to Cloudera without having made an investment. You can run the Sandbox on your laptop. It takes 4 gig of memory. So if you've got 8 gig on your laptop or your desktop, you can run a simulation. And many of the Hadoop developers run the Sandbox environment on their local machine, get everything tested and running, and then copy it over to the cluster and let it run. Typically, they set up reports that'll run on a nightly basis, and you let that run against all of your data set on a nightly basis, whereas on your laptop, you'll just take a small sample data set. Okay, so big data and Hadoop. So big data is still taking off pretty heavily. Hadoop, people are realizing Hadoop isn't the solution for all of big data, so don't get overly invested in that. This is taking a look at what the job skills that are in demand off of dice.com. Indeed.com has 4 to 6 times as many listings, but I found it was easier to analyze the data off of Dice. So there are lots of Hadoop ecosystem products, and you can't possibly learn all of them. So which are the ones that are in highest demand? So Hadoop, Hive, Pig, and MapReduce are core within components within Hadoop out of the box, as well as HDFS. You generally want to learn those for any type of solution. Many of these others are just not in as high a demand. And then take a look at what databases you're interacting with. Hadoop doesn't interact with the most popular databases. So Oracle SQL, there's 7,000 people looking for Oracle people, but only 370 compared to NoSQL solutions, particularly columnar data. The NoSQL tends to be graph or document databases and columnar databases. So HBase, Cassandra are columnar databases that are quite popular. Particularly, you're not grabbing all of the records of information. You want just a column, and you want to find an aggregate value for what's the average volume for this column, what's the highest value for this column, what's the lowest value for the column. So a columnar databases don't store things in rows where you've got to retrieve or scan over the whole set of data. Give me just a column very rapidly out of it. Some of the other Hadoop skills, so Zookeeper, I've got to take a look at that, but many of these other solutions are very specific solutions. They're not in high demand, but Zookeeper does have a high salary demand, and it's generally used to manage very large clusters of systems. So this chart is interesting in terms of people have shown big data analytics can give you significant performance increases. So these aren't 7% increases. These are, if you're doing big data analytics, you tend to do your enhancing communications and collaborations 7 times better than the competition that is not doing the big data analytics. So if you're not doing big data analytics and your competition is, you could be in trouble. Department stores, stage stores did big data analytics. They improved their sales by 6.5%. Macy's increased their sales of 25 billion by 10%. Sterling Jewelers, they said that they increased their sales by 49%, but their bottom line numbers didn't go up that high, whereas Macy's sales have been going up 14% per year. So some numbers lie. I personally don't believe that 49%. It might be just their web sales went up 49%. Hadoop's people think of as the solution for big data. It's the popular solution for big data. I'll go through these quick. Where did it get its name? It's from a toy elephant that Doug Cutting, the originator of Hadoop, his 2-year-old son had that toy elephant, so it's named after that. The elephant theme is big within the all of the ecosystem products. The Hadoop distributions are like Linux distributions, so similar to Red Hat, Fedora, SUSE Linux. Hadoop is open source, but people provide value add. So Cloudera has been around since 2009. They've got the big market share. MapR, not as heavy. Hortonworks is doing pretty well, and I like them because they have nice tutorials to learn by. The MapReduce is helpful to learn the concepts of. Jim Lose's discussion starting at 4 o'clock will have some background on MapReduce. The MapReduce is being replaced by directed acyclic graphs. It tends to get a lot more complex than MapReduce. That MapReduce is considered old and slow, primarily because I don't have this slide. MapReduce does a lot of disk writes. Every operation it tries to save the data to disk, and a lot of the new solutions try and keep everything in memory. So MapReduce is popular, but it is being actively replaced. HDFS is how Hadoop stores the data across all of those disks. It triplicates the data, and it makes it available on each individual node where you do the processing. So the idea is put the data that you want to process directly on the node that you're going to do the processing on. And generally, every solution within Hadoop is using HDFS. So all of these solutions down here, HDFS is appearing as the underlying data structure. It's just a very simple way to be able to pull in your data and save it to HDFS. The programming interface is how to retrieve the data. You go to these solutions like Hive, which is very similar to SQL, select star from New York Stock Exchange. Has a lot of different file formats, and depending on the languages that you're using, you want to take a look at, can I read and write to different file formats? Different file formats will do better compression, but if you over-compress the data, it will take longer to retrieve the data from the compression. Pig is optimized. It's a whole new programming language that's optimized around MapReduce. The general idea is load the data, transform the data, and then save the data. So it tends to be fairly straightforward. It's a new language for people, but tends to be fairly simple operations that a lot of people can pick it up in a day or two. The syntax and the breadth of the language is not too much. It's simply designed around making it easier to use MapReduce. Big downside, the debugging is atrocious. You get errors like job failed. That's just not helpful. But if you do the command line interface for it, you will get a lot more debugging information out of it. The different formats for Pig, a lot of the file formats you can load only, you can store only, and then a limited set where you can load and store. And for debugging, dumping will say, show me the output, and then describe and illustrate will say, I've built a structure. Has the structure succeeded the way that I want? It will tell you what you're really looking at. Within the ecosystem here, so I'll run on for about 3 more minutes. We've got other sessions starting here at 4 o'clock, and we may get kicked out as the next person comes in to set up. So please, if you want to head off to the next session, please get up. I'm not offended. So I know that you guys want to learn as much as you can, so get out, especially if you need to make a bio break between the next presentation. There's a lot of ecosystem products that are layered on top of HDFS. A lot of them are programming interfaces or pulling data in from different places. The Hue interface is the web interface to Hive, Pig, and your file browsing. This is the Hortonworks interface. Cloudera has a better interface with additional visualizations that Hortonworks does not have. So big plus for Cloudera there. A lot of the names are strange, so I'm going to quickly go through where Flume got its name because it reads logs. So log flumes are popular. Okay, that's how to remember that. Scoop, the way to remember that is it's SQL and Hadoop, so it's SQ and OOP. So Scoop, SQL, pulling in with Hadoop. Ambari is the structure on top of an elephant's back. Ambari is for monitoring your Hadoop cluster, building out the Hadoop cluster, and configuring it. And Uzi is the person on top of an elephant, the driver for an elephant. It's a Burmese term, and Uzi is used for workflow scheduling. Lots of people want to submit batch jobs, so it's the driver for Hadoop. And Mahout is the same thing in Hindi. It's the elephant driver, but think Mahout begins with M is machine learning.
I did, yeah.
Hortonworks is Hortonworks too. Columnar databases. The Hortonworks Sandbox. You'll need Virtualbox. So download Virtualbox. Download the Sandbox from Hortonworks. You can get up and running in 5 minutes. Boot up the environment, and it does a lot of walkthroughs. I suggest going through the tutorials in this order. The tutorials are listed in new changes above the introductory. So go through the introductory path. Don't start with the latest and greatest within Hadoop. You also want, there's a 2.2.4 version that's available of the Sandbox. The tutorials are built on 2.2, so use the 2.2 Sandbox. To interface with it, you go to port 8000 is the Hue interface, the Ambari interface is 8080, and then registration, tutorials, and introduction is 8888, and SSH is 2222. It tells you on port 8000, the different versions that the Sandbox came with Hue, Hadoop, Pig, Hive, Uzi, Ambari, HBase are configured on the Sandbox for you, so you don't have to build and download those individually. The future, MapReduce is going to be replaced by Dataflow, Impala, It's very fast, it runs in memory, but if you run out of memory, you pull in too big a data set, it just crashes and it stops processing. Very fast Cloudera product, I like it, but the advantage of Spark is it's in memory. If you run out of memory, it starts writing it to disk. There's a couple of getting started guides there. And Anand presents at a lot of the big data events. He's got a number of examples for Spark. Spark is going to take off like gangbusters. And where do you go from here? This is the last slide. Sign up for the Hadoop user groups and Utah Geek events. They do a lot of regular events, a lot of learning opportunities on Hadoop. And if you want to try out a cluster on Amazon Web Services, this is a 40-minute walkthrough on, you've got to put a credit card down to pay for the cluster space. When I ran through a test on it, it was $13 to run through a test that ran for 4 hours on some slow boxes, so it's pretty inexpensive. And then within your organization, a couple of things to consider. So I'm going to wrap that up and let the next person, who's presenting?
I don't think there is any.
Oh,